So the question that I'm going to explain a little bit more is going to be number 3, and that's describe the nerve regeneration in the PS or in the PNS. So we have PNS nerve regeneration. So this is going to happen when we have a damaged neuron. So I'm going to draw over here. We'll just pretend this is a neuron, right? So here's my neuron, right? And here's my axon. And then here's the dendrites coming off. Right, so there's my dendrites on the right side. My axon is going to be the tube-like structure connecting the body to the dendrites, and my body is going to be where I have that red circle. So for a nerve to regenerate, we automatically have to think that it has been injured. So what I'm going to draw here is, we know that some neurons are myelinated, and this allows for saltatory conduction. So that's what these little boxes are. So to illustrate the nerve regeneration, I'm going to automatically assume that something has happened to my nerve. I've injured it in some way. So for it to be a little clearer, I'm going to change the color here, and I'm going to highlight this area here. So we'll say that this area here has actually got a little bit of an injury. So we'll say it's kind of rugged here between the myelin sheaths. So we'll say that's an injury. So what's going to happen is we're going to kind of zoom down and zoom into this area of injury. And what's going to happen is you're going to see the axon here. We can see it's kind of rugged, right, from our injury. And then we're going to be surrounded this axon by our myelination. So our myelination would be here. And it's going to be kind of broken as well because the nerve has been broken in a way. So we have our myelin sheath here, and I'm going to draw it to where it has kind of layers so we can tell the difference here. And so we have our layers in our myelin sheath, and then we have, it's broken on one side here, illustrated, and then it's going to have like the myelin sheath here is going to be kind of just remaining from the break. So this would be, let's see, I can do the text here. So our proximal stump is actually going to be on the side where our myelin sheath is encapsulating our axon. And if we remember correctly, this right here is going to be our axon fat line. So what I'm going to do is I'm going to actually color that in for you guys so you can see it a little bit better. I'm going to color it in blue. So just give me a second so I can highlight this for you. So that's my axon there. Now, to illustrate my point here, we've had an injury. So our axon on the proximal stump is going to be holding up fairly well. On the distal stump, which is this area over here, on the distal stump, it's kind of going to be broken up. So because we have an injury, we're going to have little pieces of axon floating around. Like so. And you're going to have little pieces of myelin kind of floating around too because it has been broken off. So what we have here is, for our step 1 so far, we've had an injury occur to our axon, right? And in step 2, I'll highlight that here. So step 2, we've had fragmentation of the axon. So the axon has broken apart, and the myelin sheath has as well. And this is going to occur in your distal stump. So for step 3, you're going to have our immune system come into play here. And this is where we have our macrophages come in. So I'm going to draw that in a different color so you can see. So we're going to have our macrophages end up coming in here in green, and they're going to help clean up this area. They're going to clean up the distal stump. So what's going to happen now is we're going to get something that looks like this. This will eventually look like step 3, where we again have our axon here, but it's going to start to grow back, and it's going to kind of look like fingers reaching out at this point, but it's going to start to regenerate. So we have our myelin sheath here, and it's continuing to grow with this axon. And then that's our proximal stump here, so I'll label that as PS. And then we're going to have our distal stump over here again, but it's going to start to become cleaned up. So instead of looking kind of a mess like in step number 2, it's going to look something like this. So you're going to have your myelin coming out here. You're going to have your myelin on the bottom as well. And then you're going to start having your macrophages. And your macrophages, remember I drew them in green. They're going to start coming up here and kind of layering themselves just to make sure everything's clean and ordered. And you're going to continue to see macrophages just floating around so they can clean up the area. So instead of having a lot of debris left over, you may have a little bit here and a little bit there, but nothing too much. So maybe you'll have a little bit of debris here and a little bit here, but nothing as much as up in step number 2. So now, here in this step that I just drew, we're going to have our Schwann cells, or our myelin. Remember, that's the same name. It's going to start to grow, and it's going to end up uniting the stumps here. So our proximal stump and our distal stump will start to combine. So here you see like this axon here. I'll color it in darker for us to so we can establish what's what here. So we have our axon here, and you can see that it's starting to grow, and it's kind of reaching for our distal stump. So we have that kind of growth there, that it's leaning and it's moving towards our distal stump because it's trying to reconnect them. So that's step number 3. Now I'm going to erase this so I can continue drawing out the steps. So I'm going to erase this. And I'm going to start from step number 4. So remember in step number 3, we had our myelin kind of reaching out for a distal stump over here. So we had our macrophages, right? And it's kind of starting to look like this. So our proximal stump is trying to meet up with our distal stump. Now in step number 4, like I said, we're going to draw here. It's going to start to look a little bit different. So what's going to happen is our axon is going to rejoin up with the distal segment. So what's going to happen here is we're going to see our axon kind of bulging, right? And then it's going to start to kind of grow into that distal stump. So what we have here is we have our myelin sheaths, remember, because that helps for conduction. And you're going to start to see that here as well. And so now we can see that our proximal stump here that I'm coloring in, we can kind of see that the fingers have actually attached and started to grow. So remember, these were the fingers here, here, and here. So let me spotlight that for you. The fingers were up here, right? That's what I was referring to as fingers, because that's what it kind of looked like. And so the fingers are starting to regrow into the distal segment. So what you're going to have now is your axon is going to send buds into the network of Schwann cells, or our myelin sheaths, and then it's going to start to grow along the cord of Schwann cells. So here we still continue to see our macrophages just hanging out. But the main point in this step 4 is that our proximal segment is connecting to our distal segment via that area. So after this happens, we have step 5, which is the last step in the drawing out process. So now we're going to see that our axon, let me change back to pink, our axon, I'm just going to outline it here. So we have our myelin here, and our axon running through it. And so here's our axon running through this bottle shape. And we see our myelin sheaths coming out here. And then, so this was our proximal segment on this side, correct? And this was our distal segment over here. We can see that it's thicker. The axon itself is regenerating, so it's thicker on the proximal side because that was where it was uninjured. Remember, our distal segment was where the injury occurred because we had all that fragmentation and we had the debris that needed to be cleaned up by the macrophages. So now we have a smaller axon, a skinnier axon in the distal segment. And what's going to happen is our myelin is going to start growing back, but it's going to be kind of smaller than what we see in our distal segment because our axon width is a little bit smaller because it's still working on the regeneration portion. So here in step 5, we see that the axon is continuing to grow into the distal stump as illustrated, and it's enfolded by Schwann cells, which is shown there and there. So once the Schwann cells begin to regenerate in the distal segment, we begin to see that the myelin sheath is reestablished, which will allow for saltatory conduction to take place. And this process allows the axon to have innervation regained. So that allows for a certain signal to be transmitted through this axon. When it was injured, remember we had the interruption in the axon where it wasn't touching, so we couldn't conduct in a signal. So now that they're connected again and they're beginning to regenerate, we can start to use that axon again to conduct a signal to another part of the body or to another organ. So that is how PNS, nerve regeneration, happens.